We are given a damped oscillation with a frequency. We need to find the damping coefficient beta if initially velocity is 0 and displacement is eta times less than amplitude. So let's write a standard damping equation. So x equal to a naught e to the power minus beta t cos omega t plus alpha. So we don't know the initial phase, so let's take some variable as alpha. Now we have given the velocity is equal to 0, so let's differentiate so that we get a term of velocity. So it's given x dot is 0 at t is equal to 0, so let's put the value of t is equal to 0 here, and we get tan alpha is equal to minus beta by omega. Now second, it is given that displacement is eta times less than amplitude. So at t is equal to 0, amplitude is a naught. So a naught by eta is displacement at t is equal to 0. So at t is equal to 0, displacement is a naught cos alpha. So a naught cos alpha is a naught by eta. So this gives cos alpha is 1 by eta. So these are our two equations, and our variables are alpha and beta. So let's eliminate beta. So we'll square this equation. So we get a term of sec square alpha, and we'll put the value of sec square alpha from here, and we get the answer beta to be this, since beta is positive. Now one thing, he has not asked for the value of alpha, but if it did, you can see that since beta and omega are positive, tan alpha is negative and cos alpha is positive. So that means alpha must lie in fourth quadrant. So this information is not relevant in what he has asked, but if he did ask about alpha, we should know about this. The second interesting thing here is, so how come the peak of the graph is not the amplitude? So that's the case here. See here, at t is equal to 0, x dot is 0. So that is the peak of the curve. But amplitude is greater than that. So amplitude is greater than displacement even at peak. And amplitude is equal to displacement slightly ahead of that. So that's the interesting thing in damped oscillations, that peak value is always less than amplitude. And the displacement and amplitude become equal a little bit ahead of the peak. So here the slopes of both the curves will be same. So here a is greater than x and here a is equal to x. So let's write that also. So at point 1, that is the peak, amplitude a is slightly higher than displacement x at peak. And at this point, they are equal little ahead of peaks. So quite interesting, we should know this. All right.